In this example problem, we are going to make a forecast using time series data. What we've got here is a staffing company trying to predict how many people they're going to need based upon how many calls they expect to receive in the upcoming days in the future. And to do so, they're going to make a prediction based upon the series of information they have for the preceding time period that they operated within. So the first thing that we have over here is info from the last 21 days and how many calls this call center received during each one of those days. In A, we are asked to construct a 3-period moving average for making forecasts. And what that means is that we are going to assume that the predicted amount of calls they're going to get during any given day is going to be equal to the average, the mean average of what they got during the last 3 days. So starting over here, I can figure this out as the average of the 3 prior periods. Now we can't do this for days 1, 2, and 3 because we won't have 3 days worth of information to work with. But starting with day 4, I can start to figure out what the average of the prior 3 days was by using the average function. So this is equal to the average of days 1, 2, and 3. And that comes out to be 295. So based upon that assumption that we expect, let me make this a little bigger so everybody can see it, we expect the number of calls on any one given day to be equal to the average that they got for the last 3 days. Day 4 should have had 295 calls. And I can just fill handle this in all the way down, and we get the average for each of the preceding 3 periods. And with that, we can figure out the residual. This is actual information right here. So on day 4, we received 294 calls, actually. Using the 3-period moving average, we would have predicted 295 calls. So how do we find our residual, RE? Well, it's the actual value of Y, the number of calls that we got, minus what our prediction would have said. 294 minus 295 means that our prediction was 1 off from what we would have had originally. The actual amount of calls was 1 less than what our predicted model said. Filling that in all the way down the line, and we get the residual for each and every day that we had. How many calls that we were off from the amount that we had predicted in this case. And I know you can't get 2/3 or 1/3 of a call. Don't worry about it. You'll be fine. So with that information, we want to create a line graph that plots the number of calls in the accompanying 3-period moving average against the number of days that we have going on. Well, how am I going to find that information? How am I going to make that graph? Well, what I got to do is I just got to plot the number of calls that we received in an actual day against the predicted value we had, our Y hat, the average of our last 3 days. And I can go through, I can highlight all that information. I know I want X to be the number of calls that we actually had and Y to be our predicted value. And we're going to have days be the overall total. So I'm going to highlight everything here, and I'm going to go insert a line graph, and I'm going to pick this guy, and there's the return that I get. Our x-axis is the number of days, and I have both of those figures on my y-axis. Call the chart title that we have here the number of calls v our moving average. And we can insert some axis titles if we wish to make this a little bit more easier to read. We can call our y-axis the number of calls, and we can call our x-axis day or days. And this graph is ugly looking because we got tons and tons of empty space down here. We have nothing in our data set that has a point lower than 250, so all the beginning of this is just unnecessary. I can go and I can format this axis, and I'll put my minimum bound. That's 250. And there we go. That looks much prettier. So what we have here is the blue line is the actual number of calls that we received, and the orange line is our predicted value according to our 3-period moving average. That being said, somebody looking at this would say, Y hat, what does that mean? That's a terrible thing to have as a label because no one understands what it would mean. We can easily fix that. If I just click on this and I right click, I can select the data, and where it says Y down here, I can click on that guy and I can edit, and in the top range I can change the name to anything I want to that'll make it easier to read, we'll just call it the 3-period moving average. Now I can close this guy, hit OK on this thing to close it out, and that looks like a much better assumption. So as we see here, our line is bobbing and weaving in between what actually happened. There's a little more volatility in the actual number of calls that we had, where our line for the moving average looks a little bit smoother, and it kind of makes sense. And you can also see in here that our moving average trails a little bit to what happened. Like when the dip happened here, our moving average didn't dip till another couple of days later. When the dip happened here and here, it doesn't dip until over here. And when the dip happens here, the dip doesn't happen until over here. So the moving average trails a little bit on what happened. It makes sense if you're making information off the last 3 days, you're not going to have up-to-date information. But we do have a functioning graph right here that shows that it's at least close, and this methodology does a pretty decent job of making a prediction. Well, let's use that then to figure out what our forecast is going to be for day 22. How would I figure that out? Well, what's the assumption we're going with? That on any one given day, we predict that the amount of calls we're going to get is going to be equal to the average of the last 3 days. And in this case, the last 3 days before day 22 would be days 19, 20, and 21. So it would be the average of 326, 327, and 309, and that comes out to be 320.67. But how good of a predictor is this really? Well, I mean, the graph shows that we're pretty close over here, but we can take some more advanced metrics if you wish. And the first is going to be the mean square error. And I have the formula listed in the box on the side over here for us to do. All this really is the average of the square of our average residual. So I can put that in as it's equal to the sum squared of our residual range, and that will be everything that we have marked by E. So all the way from cells D5 down to D22. Divided by how many residuals we have, which we can find as the count A of that very same range. And we come up with 221.19. I missed one in this one, sorry. That's supposed to go to cell D22, not D21. You fix that situation. D22, there we go. That looks better. 208.90. The mean square error is kind of hard to assess if you don't have something to compare it to, but it just in general, it is more punishing to sets that have larger variances in the case. And I don't mean on the average, I mean just any single one residual being very large outlier compared to everything else, because when you square something, it grows exponentially. So the mean square error is a good measure of how close something is compared to another model, when it's really, really bad to have a huge variation. But for other purposes, you can find something a little more straightforward, like the mean absolute deviation. And basically, that is how far, on average, any one residual will be from the actual point that occurred within our data set. So you can find that out over here as it being equal to the sum, open a parenthesis, ABS, which is Excel's absolute function, of the residual range, the same cells that we had before, D5 through D22. Close both of those parentheses, and we'll divide it by count A of the residual range. And we come up with 11.85. So what we're saying here is that on average, our model will predict a number of calls that is within 12 of what actually would occur during the period. It could be more, could be less, it's the absolute value, but it's a metric that we can use to compare the likeliness of this to, say, another methodology we could use for making predictions. And then lastly, we have the mean absolute percentage error, which is very similar to the MAD, if you will, the mean absolute deviation, but instead of expressing it in terms of how many number of calls you're going to miss by, it's by what percent of your prediction you would miss by. So to do this, the first thing we're going to have to do is we're going to have to find the absolute percentage error, and that's the formula that we have up here. The absolute value of the E value that we have here divided by the actual value at that point, all close up, divided by, or times, excuse me, the 100 to convert it to a percentage. So over here, for cell E5, what I can say here is that this is equal to the absolute value of the residual that we had for that particular day, which was -1, close the parenthesis, divided by the actual value we had for that day, which was 294, close that parenthesis, and then we'll multiply it by 100 to express it in terms of a percentage. And we hit OK. I don't know what happened there. Here, sorry about that. I didn't put the parenthesis in the beginning right there. There we go. I just taken the absolute of this and to understand. There we go. Equals parenthesis ABS D5 divided by B5, close the parenthesis, times 100. Work that time, 0.34. And if I go down here, I can fill in the whole thing, and we get what percent our estimate was off by based upon the actual number. So our estimate, our miss, if you will, our residual for day 4 was 0.34% of the actual calls that we had. And now for the mean absolute percentage error, I can fill in that formula as it's equal to the sum of our absolute percentage range divided by count A of our absolute percentage range. And again, this MAPE is going to be very similar to our MAD, if you will. Just in terms, it's not in terms of the number of calls, it's in the terms of percentage. And what we're saying here is this model, this methodology for making predictions for forecasting is going to give us a prediction that should be on average within 4%, 3.92% if you will, of the actual number of calls that we receive during the period.